Good morning. I am Dr. Fatima. Today I am taking experiment number 4 of control system via MATLAB. Subject code is EC404. Experiment number 4 is polynomial presentation and zero pole gain ZPK for transfer function. We start experiment number 4. See here, the aim of this experiment is represent the polynomials in MATLAB, find the roots of the polynomials and write the transfer function for given location of 0 and pole with gain. The MATLAB provides the functions for standard operations such as polynomial roots, polynomial value and its evaluation. MATLAB represents polynomials as row vectors containing coefficients ordered by descending powers. For example, consider the equation px equal to x cube plus x square minus 2x plus 5. So you can see here this polynomial contains the coefficients, contains the value of x ordered by descending powers. So the coefficient of x can be written like this: p equal to, within square bracket, the coefficients can be written. So see here, px is equal to x cube plus x square minus 2x plus 5. So I can write the coefficients of this polynomial by, let it be p equal to, then within a square bracket I can write the coefficients from the highest order of the x towards least order of the x. So here you can see x cube is the highest order and the coefficient of x cube is 1. So I wrote here 1, then give space and write the coefficient of x square. You can see here the coefficient of x square is 1. So I write here 1. Then 2x, the coefficient of x is minus 2. So I write here minus 2 and coefficient of x raised to 0 is 5. So in last I wrote here 5. Now I am copying this command and executing here. So you can see here the coefficients are written here. So p equal to 1, 1, 1, minus 2 and 5. So this will connecting us soon. So you can see here the polynomial values can be written in coefficient form. That is, polynomial can be written in coefficient form. Now if we want to calculate the polynomial root, this can be calculated with the help of the syntax roots, within parentheses write the polynomial variable. Like I have taken here one example, r equal to roots within parenthesis p. Since p I have already wrote here the value of p, so I can write here r equal to roots p. So this command will give the roots of the above polynomial. The above polynomial is x cube plus x square minus 2x plus 5. So you can see here, the coefficients of the polynomial are written here. I am writing here r equal to roots, write r equal to roots, within parenthesis write p. Since the p is already declared here, the polynomial coefficients are already declared in the value of p. Here the capital P is using, so I am writing capital P here. Now this will calculate the roots of above polynomial. Polynomial was x cube plus x square minus 2x plus 5. So here the highest power of x was 3. So here 3 roots are calculated. So the root can be calculated by a command roots in MATLAB. So roots can be calculated with this command. Now next, the polynomial function value can be calculated by putting the value. See this syntax, poly val is written for value. Within parenthesis, the polynomial variable is given and at which value you want to calculate the polynomial value. So that value is also written here. X, the value of x is taken equal to 5. So I am taking this term. So I am executing here. Poly value, here capital P we have taken. So I am writing here capital P. Poly value will calculate the polynomial value at x equal to 5. Now you can see here the value of x is equal to 5 and it calculates the value of this polynomial. Now next command. See, I have taken one more example. Calculate polynomial roots of s raised to 7 plus 8s raised to 6 plus 5s raised to 5 plus 4s raised to 4 plus 3s cube plus 2s square plus s plus 1. So the coefficient of this polynomial is written in here. X equal to 1. S raised to 7 polynomial, sorry, s raised to 7 coefficient is 1, s raised to 6 coefficient is 8, s raised to 5 coefficient is 5, s raised to 4 coefficient is 4, s cube coefficient is 3, s square coefficient is 2, s raised to 1 coefficient is 1 and s raised to 0 coefficient is 1. Here 1 is missing, so I will write here, I am writing here. One more 1 is present here. Now see this, the polynomial coefficients are decided here. Now calculate the roots. Let it be y equal to roots, within parenthesis write x, since we have defined the polynomial coefficients in x. So I wrote here roots x. Now you can see 7 roots are calculated since the highest power of this polynomial is x raised to 7. Similarly, the poly value can also be calculated. Like I am writing here, let it be z equal to poly value at whatever value you want to calculate. Let it be at value of 10. Now this will calculate the value of this polynomial at x equal to 10. Now come to the next part of this experiment. Create transfer function through zero pole gain. If the zero pole gain is, that is if zero pole location are given and gain value is also given, we can write the transfer function with the help of that. So zpk is the command to write transfer function in MATLAB. ZPK can create the transfer function if 0 and pole locations are available and if gain value is available. Now this is the syntax of ZPK. ZPK is written for the writing of transfer function in MATLAB, and within parenthesis write the location of the 0, location of the pole and value of gain. Location of 0 and pole are written in square bracket and value of gain is also written in square bracket, and all these values are written in parenthesis. So this command, I am copying this command. See here this example, I have taken sys equal to zpk command, zpk within parenthesis. Now see, 0 is written within a square bracket. This 0 is the location of the 0. Now minus 1 and minus 1 are written in square brackets. This minus 1 and minus 1 are the location of the pole, and in within a square bracket 1 is also written. This 1 is the value of the gain. I am taking this term. See here, sys equal to zpk 0 minus 1 minus 1. फिर next is 1. Location of 0, location of pole and gain value are separated by comma. Now see here, this has given the transfer function. So the transfer function can be written with the help of zpk command also. Now I am taking one more example of this. I am taking more complicated example. See here, this is more complicated since I have written here. See, so the location of the zeros are given here, location of poles are given here, and and the gain value is given here. Now execute this one. So you can see the more complicated transfer function is written here. So with the help of zpk command, the transfer function can be written directly in the form of s. So this completes this experiment. Thank you.